I want to do one example of rotating these things around a point that is not 0, 0. So first thing I want to do is take this point 3, 7 and rotate it around this point 8, 9. Okay. The approach that I gave you yesterday was to place these axes in there, right? Okay. Place those axes in there, and then you start to relabel things based off those axes. So I'm going to relabel this as 0, 0. And what does this relabel as?
Negative. No.
And I'll zoom in to make it. There we go.
I got a new math notebook. -4, -5.
Careful. If I go from here, this is 0, 0 now. -5, -2. -5, -2. Okay. Now that is the point that we're going to rotate. Okay. And you can use whatever rule you want to. Let's just use the rotation of 90. We've been using that one quite a bit. The rotation rule says if you start with an ordered pair A, comma B, where now A is this -5 and B is this -2, when you rotate it 90 degrees, it's going to become the opposite of B, comma A. Okay, so if I take -5, -2, and I apply this rule to it, it's going to take and rewrite it as -2, -5. But then you need to negate this, right? You need an extra negative in front of this B. So what's the negation or the opposite of -2?
2.
Yes, positive. Okay. So now what we're going to, so 2 comma -5. Keep that in mind. I'm going to kind of zoom back out here. 2, -5 was what we found, right?
2 comma -5.
Yeah, 2 comma -5. And that 2 comma -5 is going to be placed off of this point here being 0, 0. Okay, so that's 0, 0. We're going to go 2 and then down 5. Okay, so 2 to the right would be there, correct? Because it's going by 2s.
Yeah.
So 2 to the right and then down 5. So there's down 1, there's down 3, there's down 5. So we get that point right there. And what would you call that point based off of the original or the true origin here?
10-4.
You'd call it 10-4. Okay? So if I ask GeoGebra to take this point A and rotate it around R 90 degrees counterclockwise, does it show up right there at 10-4?
Yeah.
Yes. Okay. Where if I don't change this 8, 9, and I just start or the 3, 7, and I say I want to rotate 3, 7, and use my rule that says A, comma B is going to turn into the opposite of B, comma A. If I don't change 3, 7, I would get -7, comma 3, and that is not this number here, right? Does that make sense, everybody? Okay. So we need to make sure that we go through that process. What I want to do today is kind of walk back through, because we kind of ended class yesterday talking about this, but I want to go back through and see if we can develop an idea for how we can algebraically rotate these things instead of having to have the graphical image in front of us. So yesterday, and just previously, we made this 0, 0, right?
Yeah.
Okay, and this became -5, comma -2. How can I find that -5, -2 with these numbers of A and R that are 8, 9, and 3, 7? I subtract. Okay, so I can say that this -5, -2, so the point that we rotate, can actually be found by taking the x value of A, and that's A right there, so that x value of A, and subtracting from it the x value of R. Does that make sense to everybody?
Yeah.
And then comma, the y value of A minus the y value of R. Okay? So let's see if that works. Let's see if I used 8, 9. Let's see if we can use a different point. Let's go 6, 8, and let's do Let's do 2, 4. See what happens if we use that information. So if I use x sub a, so use this 2, and then subtract from it x sub r, which is 6, and then go y sub a, which is 4, subtract from it 8, which is y sub r, that should give me -4, -4, right?
Yeah.
Is that what this point would be if I go from here being 0, 0? Do I go to the left 4 units and then down 4 units? Does that make sense? Okay, so that's the point that we want to rotate. Okay, so -4, -4 is going to be the point that we are interested in rotating. Now, here's my thought on this, guys, and this is why I'm showing this to you. If I have that formula, it now makes things a little bit easier. I'm going to go back to something I had earlier up here. It now makes the question of rotating that triangle, rotate it around this point, 8, 9, 90 degrees. It makes it so much easier. Instead of having to count and rename every one of these points, okay, can't I quickly find those points by doing something like this? And I'm going to do my work over here and see if we can keep the picture in here. All right, so we said that A, let's see if I can hide this stuff. All right, we said that A was located at initially 3, 7, right? Okay, I'm just going to write that is X, comma my port, or X sub P, and P just standing for the point that I'm dealing with, and then Y sub P, okay? If I take that and try to write the format for how I get this to transform into point A based off of this being 0, 0. So if that was 0, so we walked over -5 and down 2, right? So it's -5, -2. We said that was created, and I wrote that formula. We said it's X of P, minus X of R. I think I used A earlier because it was point A. And then Y of P minus Y of R. Okay? So right now I'm rotating around 8, 9. So I'm going to put 8, 9. I should write 8, 9, I guess, right here. And that is X of my R, X of my point of rotation, and this is Y of my point of rotation. Can I take 3, 7, where X of P is 3, minus X of R, which is 8, comma YP, so Y of P is 7, minus Y of R, which is 9. Does that end up giving me -5, -2? And that's the exact same thing that I would have gotten if I would have called 8, 9, 0, 0, and then counted over that many units, 5 units that way, and down 2 units to relabel that point as -5, -2. Is that okay with everybody? Because I took 3 minus 8. I take the x value of the point. So now, if I can do that with A, can't I do that with B? B is located at -3, 4, right? Okay. I'm going to take the -3, subtract 8 from it, take the 4, subtract 9 from it. And what's -3 minus 8? -11. What's 4 minus 9? -5. Was that pretty quick in finding that this point right here, named off of 0, 0, should be left 11 and down 5? That was a pretty quick process, right? You can, but what if I make this number, what if I make this -3,000, comma 4,000? Do you want to count that? No. Okay? So we have to be able to have some approach that allows us to do numbers that are not all that comfortable to deal with. What if I look at C here, being, it's at 5, -6. Can I take 5 minus 8, -6 minus 9? What's 5 minus 8?
-2.
-3.
Oh, no.
And what's negative 6 minus 9? Negative 15. Okay? So what I'm trying to show you here is that once you understand the concept with 1 point, where I subtracted 8 and subtracted 9 from the x's and y's, is that the same thing that you do for every other point? Yeah. So that gets every one of these points over here in the picture. It gets every one of them quickly rewritten and re-identified based off of this point 8, 9 actually being 0, 0. So this would be negative 5, negative 2. We would call this one negative 3, negative 15. And we call this one negative 11, negative 5. And that is so much quicker doing this than it is to do the counting left and right, up and down. Does that make sense?
Yeah.
Okay. Yes.
So, I understand how you find that, but why do you want that?
Because I cannot apply this rule that says rotate 90 degrees or any degree that I want to rotate. This rule that provides me the rotation of something 90 degrees clock or counterclockwise only works around the origin.
Okay.
So I have to I have to change these points so that they're in reference to the origin.
Okay, so you use the new points that we found, then you rotate those 90?
Yes. So these points, good question. These points here are the ones that you are going to rotate 90 degrees. So when I do that, let's do that. Let's rotate negative 5, negative 2, 90 degrees. That is going to provide me. So this is your A value, and that's your B value up here. So then it's going to become, I'm going to flip-flop them. And then this first one becomes negative, right? So what's the opposite of negative 2? 2. So I negate the negative, so it becomes positive. Can I flip-flop this one? Gives me negative 5, negative 11. Negate the first one. Flip-flop this one. Gives me negative 15, negative 3. Negate the first one. So these are rotated around 8, 9 as if 8, 9 was 0, 0. Okay, so going back to kind of the graphical approach, what we would then do with those numbers is say, okay, I'm going to go over 2 and down 5, so it should put me where my cursor is right now. Okay, but that point is not, in the traditional coordinate plane, is not 2, negative 5. Because the reference point that we always go back to graph points is 0, 0, right? So if that's my cursor, if my cursor was right there, at that point, how do I get there from 0, 0? Move to the right 10 units and then up 4 units, right? So I got to figure out how do I get these points rewritten as their actual values from 0, 0. Well, think about what we did initially. We subtracted away the 8 and the 9, right? And that's what transformed everything to deal with this being 0, 0. So now to get back to dealing with that as being 0, 0, what do you think I'm going to do with that 8 and 9? Add them back in. Okay? So now, I'm just going to write a column here. Put a formula up here. We're going to take, well, let's call these P prime. Okay? So that's X sub P prime, and this is Y sub P prime. Call them P prime because they are our point or our pre-image rotated. But now we need to add back in that 8 and that 9. So I'm going to write a formula here. It says X sub P prime plus X sub R, comma, Y sub P prime plus Y sub R. Okay? Now, all you got to do is take this 2. Your X sub R was 8, right? And it's saying add 8 to that. So 2 plus 8. This here is Y sub P prime is negative 5. You're going to add your 9 back to that. And now in each one of these, we subtracted 8, right? And then subtracted 9. So in each one of these, we're going to add 8 and add 9. So we're undoing what we did at the beginning so that we could address the problem. All right, so we go through that. Now, we have to rewrite these values. Okay, we need to talk about what A should look like. Okay, so what would, if this was A all the way through here, let's call this point here A prime. What would A prime's actual ordered pair be? What's 2 plus 8? 10. And then the Y value would be 4. What's B prime going to be? What's, careful. 13. Comma.
4. Negative 4. 4. Negative 3. Positive 4. 5.
Negative 2. And because that's what negative 11 plus 9 is.
Oh, I was looking at negative 5 plus 9.
That's A prime. So this is B prime. And this is going to be C prime. So what's 15 plus 8?
22. 23.
23. And what's negative 3 plus 9?
6.
6. Okay. So that is our answer. That is the points, the ordered pairs, that if I take this triangle that we started with and rotate it around 8, 9, 90 degrees. So I'm going to use GeoGebra to check to see if I've done this correctly.
Wait, so if you just end up adding them back in, why do you subtract them in the first place?
Because I cannot apply the rule. I can't apply my rotation rule because this rotation rule is written around or based off the origin. That says A comma B becomes negative BA. And if I'm rotating around that, that's not the origin, right? If I want to use this rule says that you can only rotate using that rule around that point. So what I have to do is basically make that point that one. And that subtraction of 8 and 9 does that. Okay. So let's just see what GeoGebra comes up with here if I ask it to take my triangle here, which is that there, and I'm going to rotate it around R, and I'm just going to say alpha degrees. So, and this alpha here is, I'm just going to do that rotation. So I said, what, 90 degrees? So let's see if we can get that to 90. And what do you see at the ordered pairs are for A prime, 10, 4, B prime, 13, negative 2, C prime, 23, 6. Okay? So that algebra that we wrote down there in that kind of chart almost is effectively transforming these points in that rotation. Okay? Now I'm going to ask you this question. What if they ask you to do a rotation of 450 degrees? Do we have a rule for anything like 450?
Yeah, we can Google it.
And Google's not going to give you an answer.
Yes, you just take the two rules and add them together.
Okay. Which two would you add together?
The 90 and 360. The 180 and the 270.
Okay, so that'll give you 450. That's doable. That's fine. Okay. So you're going to say, so let's try this. So let's just take one of these, and actually just to make things a little bit easier, let's actually rotate like around 0, 0, and we'll get one of these. Let's make things a little bit easier. All right, so if I want to rotate, like let's just say B, I want to rotate B 450 degrees, okay? You're saying that that is equivalent to a rotation of 180 followed by a rotation of 270, right? Okay, so the rotation of 180 is equal to, or starts off with, if I have A comma B, it gives me opposite A, opposite B. And the rotation of 270 says if I start with A comma B, it's going to turn into 270. I flip-flop them so it becomes B, A. and I negate the A. Okay? So I guess just the formula purely without. So that's the 180 rotation by itself. That's a 270 rotation by itself. Okay? If I do this, okay, I'll take 14.2. Okay? Apply this rule to it. So it becomes -14, -2, right?
Yeah.
Okay? Now take that and apply that rule to it.
So positive 14, so positive 2, positive 14. Right?
Okay? So you flip-flop them.
Rotate 90 degrees.
We flip-flop them, okay? And it gives me B comma negative A. And it gives me -214. Okay? So let's look at B. Let's say that I want to take B, point B, and rotate it around R that many degrees, okay? Now, I said 450, right? So 450 gets me, where'd it go? Just a second. So it does get me to that point, -214 that we said, right? Okay. Is that the same as rotating
90 degrees? Yes.
90 degrees?
Yes.
Okay. So your approach is fine. That's what is awesome about math, guys, is that you have multiple ways of doing this. Okay. A 450-degree rotation is the same as a 180 followed by 270. But the safest thing to do, guys, is if I say a rotation of something bigger than 360, because if I rotate, what's that shape tracing out if I rotate this? A circle. How many degrees are there in a circle?
360.
360. So if I rotate 360, don't I get back to where I started?
Yeah.
Okay. So what we do is we start subtracting multiples of 360. And if I take 450 minus 360, what's that give me? 90. So a rotation of 450 is equal to a rotation of 90. Okay? And you can do that kind of stuff. So that they might ask you, what is maybe they say rotate 900 degrees. Rotate 900 degrees. Well, if I take 900 and subtract 360, do I have a rule for a 540-degree rotation?
Yes. Yeah.
No. I only have rotations for 90, 180, and 270, right?
Well, that's all you need.
So we'll take 540 and subtract 360 again, because a 900 and a 540 are the same thing. Does that make sense?
Yep.
So I'll subtract 360 from 540, and it gives me 180. So now if I wanted to rotate 900 degrees,
You do an 80.
I'm going to do 180 instead,
Yeah.
because it gives me the exact same image. Does that make sense to everybody?
Yeah.
Okay. You're going to have a homework question like that, okay, where I ask you to take a triangle and rotate it around a point. I got home late last night, too. Dilation, okay? If the dilation is occurring with respect to the origin, then this stuff is pretty easy, okay? What's it mean for something to dilate?
Make it smaller.
Okay, get smaller or
bigger.
or get bigger. Okay,
Can they
either
dilate?
one. Okay, so your pupils dilate, right?
Yes.
Okay, so they do that to capture more light or less light depending on the conditions that you're in,
Yeah,
right?
depends where you're at. You're in night or day.
When we enlarge something or reduce something, we're going to use a scale factor to do that. Where's the other place that we've talked about scale factors in this class?
Chapters are
This
going.
way.
There's a couple chapters ago.
It's like height, like playing those
Shadows.
Okay, so we're dealing with triangles. What kind of triangles? What was the relationship we said between triangles when we dealt with scale factors?
similar.
They were similar. Okay. So when we do dilations, guys, we are generating similar figures. They're not a rigid motion or an isometry was saying that distance was saved. So when you moved or rotated a image, the pre-image and the image were congruent, right?
Yeah.
When you do dilations, the image and the pre-image are similar because distance is not saved. Okay? So dilations are not a rigid motion. Thinking about taking a number like 5, okay? Multiply 5 by 2, multiply 5 by 3, multiply 5 by 4. What's happening to that product?
They're getting bigger.
Getting bigger.
By 5.
So when I multiply by a number bigger than 1,
You get more.
I get
Bigger.
bigger. I get an enlargement.
Yeah, you get
Okay?
more.
If I multiply, what's 5 times a half?
2.5.
2.5.
Yeah.
What's 5 times a fourth?
0.25. Yeah. 1.5.
1.25. Okay. What is 5 times a tenth?
0.2.
0.5. It's 5 over 10, right? Okay. What is happening to that number?
Getting smaller.
Getting smaller as that number is. That number's getting smaller too, right? But all of these numbers are between 0 and 1, aren't they? All these fractions? So every time I multiply by a fraction between 0 and 1, I'm going to get a reduction. Okay? With dilations, and we're going to do a couple examples here, but the notation that they're going to use is a capital D, and they're going to put a number down here. Okay? I'm just going to put the letter M right now. Okay, but that is going to be your scale factor. Okay? So you might, because my S's look like 5s. So that's your scale factor. Is that okay with everybody? If I have a point A, comma B, or in this case, we call it just X, comma Y. It might be easier for some of us. If I have the point X, comma Y, when I want to dilate it by a scale factor of M, all that happens is that you multiply your X by M, you multiply your Y by M. Okay? Don't worry about it. Is that something we can do?
Yeah.
So if I have the dilation of, let's say, a scale factor of 3 for the point 2, comma 4, what's that going to turn to?
6 and then 12.
6, comma
12.
12.
What's M stand for?
M is just a number. It's my scale factor. If you were less concerned about my phone falling on the floor and paying attention, you would have figured that out.
Don't yell at me.
I'm-
It's not a signal, class.
Is this something we can do? Can we multiply order pairs by a number?
Yeah.
All right. So if we can do that with 1 point, we ought to be able to do it with 2 and 3 and 4. So I'm going to start off with our first question here, just dilating a segment. All right, so let's take a point at 1, 3. Let's take a point at 4, 2. We're going to take that red segment, and we're going to dilate it, okay? Now, this dilation only works for things around 0, 0. So our dilation point, I'll just call it D, is the origin. Okay, so that's our dilation point. Let's say I want to dilate this thing by, let's just go 3 again. So dilation of 3 of both of these ordered pairs. Okay, so what is A prime going to look like if I dilate this by 3?
It's going to be like 3 and then 9.
Yes, 3, comma 9. And what is B prime going to be?
12, 6.
12, 6. Okay, so let's write that in. A prime is equal to 3, 9. B prime is 12, 6. Okay. Now, if I zoom out to see that segment, make it blue here. Okay. We have now dilated that. Okay. And you see that it got larger, right? It got bigger. Okay. That's because our scale factor was greater than 1. Couple properties here. Couple things to kind of focus on and think about. AB's length and A prime B prime's length. So let's look at the blue segment, A prime B prime. Its length right now is 9.49, right? The green one is, or sorry, the red one is 3.16. Can I take A prime B prime and divide it by AB? So that's taking this number here, this blue number, divided by the red number, and it gives me 3. Does that make sense?
Whoa.
Why does that work that way? Why does it give me 3?
Because our scale factor.
Because our scale factor was 3. So we enlarged this by a factor of 3. So distance was changed by a factor of 3. Okay. If I look at some other things here, let's look at Let's put a ray on D, start at D, and let's put it going through A. What other point do you see that it goes through?
D. A prime.
A prime. If I put a point on D
B prime.
and then make my ray go through B, where does that go through? B prime. Okay. I'm going to do something real quick here. I'm going to create just some arbitrary number M, and then I'm going to take my x value from A and multiply it by M. And we'll take the y value of A and multiply it by M. So what I hope you're seeing here is I'm taking that ordered pair where my cursor is, and I'm multiplying it by some arbitrary M value, some scale factor. And I'm going to plot that point and see what it looks like. And because M is 1, it puts that point C right there on top of A. I'm going to do the same thing for B. So I'll take the x value of B, multiply it by M, comma, the y value of B, multiply it by M, and it should, because M is 1, put a point right here on B. But now as I move M, it starts to move those points, right? Okay, so I'm going to connect those because I should have a segment here. And let's just make it dotted so we can talk about it a little bit easier. That dotted segment, will it eventually be A prime, B prime? When my scale factor is 3, right? So you see how this dotted segment is representing all the different dilations that are possible of that red segment? Does that make sense to everybody? Okay. Of all those dilations, do the endpoints ever leave those two rays? No. Okay. So when you do dilations, okay, your image and your pre-image should end up on those rays. Okay, they should be shared by those rays. Here's another kind of relationship that exists here. Let me just hide this. If I look at the length D to A, so that distance right there, and let me just use a different color. If I look at that distance D to A, and I compare it to that distance D to A prime, what do you think that relationship will be?
3.
It'll be 3. Okay. If I take D to A prime divided by D to A, you see that it evaluates to be 3. What about D to B prime divided by D to B? What's that going to be?
3.
3. Okay. What if I asked, let's think about it this way. Let's draw this conclusion. This might be helpful for some of you on your homework. If I look at going from D to A, can I use a slope idea? Can I go a rise of 3 and a run of 1? Does that make sense? A rise of 3, a rise of 3, and a run of 1 to go from D to A. So what am I going to need to go from D to A prime that was all up there?
D to A. You're going to need log 3, right 1.
Well, if I go, okay, so
You need to do that a lot.
how many times do I need to do it?
3.
Yeah. I need to go up 3 over 1, gets me there.
Go up 9 over
Up
2.
3 over 1 gets me there again. And now up 3 over 1 gets me to A prime, right? So if my rise over run from my rotation point, from 0, 0, to get to A, that rise was 3 over 1. My scale factor is 3. So to go from D to A prime, can I multiply that by 3 over 3 and get 9 over 3?
Yes.
And there's my slope that I go from D to get to A prime. Does that make sense, everybody? Okay. Is that still a slope of 3, though? Okay. Which should be maintained because of the idea that both those points are on this line. And from any point on that line to another point on that line or that ray should be the same slope. All right, so let's do this with, let's say we have a triangle. Let's take 2, 8, 6, 2, and 2, 4. let's dilate that by, let's just make it easy. Let's dilate it by 2. Okay? So what is A prime going to go to?
416. 4. Yeah.
So A prime is going to go to 416. What about B prime?
12. 4.
12, 4. And C prime?
4. 8. 4. 8.
4, 8. Okay? So let's connect segments there. So I'm going to go A to B to C and back to A, I think. Okay, so it gives me that triangle, right? Okay. Are those two triangles the same size?
No.
No, they're different, right?
Similar.
But they are similar because if I take this one and put it right there, does that angle match up?
Yes, sir.
Does that angle match up?
Yes.
So they're similar by angle, right?
Yeah.
Okay, or that's one similarity that we can see and recognize. If I take length, let's just go A prime, B prime. So it's talking about this longer segment here. And divide it by its corresponding segment over here. Because they're similar, shouldn't that ratio be my scale factor?
Yes, it is.
And my scale factor was 2 in this case. If I start with a ray at 0, 0, and it goes through A, where else is it going to go through? A prime. If I go at 0, 0, go through C, where's it going to go through?
Prime.
And then D through B,
B prime.
B prime. Okay? And every single triangle that is going to be similar is going to be a triangle with its endpoints or its vertices on those 3 rays. Does that make sense?
Yeah.
Okay. So, for instance, if I were to take just A times M, create a slider, do B times M, and C times M, okay? And then take those points. Oh, not that one. Okay, take that point, that point, that point, create a triangle. Let's make that triangle red. If I start moving M, let's make this go to 20. Okay, so when I took the like A times 3, B times 3, C times 3, what GeoGebra is able to do is take the X value of each of those multiplied by 3, take the Y value of each of those multiplied by 3, and give me points. So this red triangle is dilation of that smaller triangle, the smallest one up there. Does that make sense? Okay, so we get all those dilations. Does each one of those red triangles have vertices on those 3 rays?
Yeah.
Okay. Sometimes you'll hear this stuff called as like a projection. Okay. If you have like a flashlight right here at point D, and you shine it.
It's a shadow.
You shine it at a 3-dimensional object. Say our 3-dimensional object here is our first triangle. Is that thing there your shadow?
Yeah.
Okay. So your shadow should be similar to your actual object. Does that make sense?
Yep.
So sometimes they call, you might hear them say, what is the projection of one object onto another, something like that. They're talking about a dilation. Okay. Is this something we can do?
Yeah, it's easy.
All right. Now they might at some point give you like A and A prime, okay, like we have up there, or give you 2 points or 3 points, whatever, and ask you what is the scale factor. Okay, well if I know the scale factor, to find other points I multiply by the scale factor, right?
Yeah.
If I'm given 2 points and I want to find the scale factor, I undo the multiplication. How do you do undo multiplication?
Division.
You do division. Okay. So if I look at let's say, what was that point? E and A. If I look at E and A, okay, and I want to figure out what the scale factor is, I take the X values and I divide them. What's 10.2 divided by 2?
5.1.
5.1. You see M up there, my scale factor is set at 5.1, right? Okay. Or if I take the 8 divided by, I don't know what it's got there, is E.
5.1.
It's 40.8, okay? If I take 8, put it into 40.8, it's going to go in 5.1 times, okay? So that's how you can determine the scale factor given the picture. You have a map Excel assignment that is
You want one?
should be open. If not, I will open it.
It is open.
I also emailed you. Okay, there is a question in your email that you need to answer. It's a rotation question.
For a grade.
For grade, you need to make sure you do it. Okay?
Does it take
And
home
it's
test?
just like the one some of you slept through at the beginning of class.
There's a take-home test Thursday.
There is a take-home
It's
test
due
Thursday.
Friday at 8:15. I won't be here.
Please pardon the interruption. We, of course, would cite